Well, like I said at core, I don't know if this meeting will go very long. We'll see if people actually have anything they really want to talk about. But I'll mention, I guess, for pull requests here, Adam and Igor, they both have a couple of new ones that are touching the pinning logic in BlueStore for the ONode cache. And these, I don't know that either of these will actually affect performance at all, but I wanted to just uh, put a label on there because they're touching code that does affect performance. So we'll
It
we'll
will it will affect performance. It will offload some of our time of looking into tracker bugs and finding out problems with on-node pinning crashes.
absolutely, Adam. I think you're right. Well, good. Those are both exciting to see. I'm hopeful that we'll never have to look at this pinning logic again, but we'll see. Okay, I saw one closed PR. Adam, this is your incremental update mode for Blue Vest log. Oh, I had something stuck in my
Indeed,
throat.
indeed it is. And now I will have to be on a very strict watch on tautology failures that might be related to this. I do not really believe that, but after any such PR, I'm on a heightened alert.
Definitely. Good that you got in though. Impressive getting in right at the end of the year like this.
Yeah, there is a second one in fine grain locking, just waiting latest reviews. I got excellent review from Igor uh, another time, and there's even more. That was a batch of even more detailed insights in the errors that I still left there.
Oh, good. I have that under the no movement category. I wondered, was that recent that he added the review? Let me check.
Yesterday and I today fixed those.
Ah, yeah, how did I miss that? Oh boy. I apparently have gotten somewhat lazy here. Okay, updated. Oh, that's because I had stolen some of these from, uh, it doesn't matter. Okay, good deal. Um, so let's see. Then updated, besides that, the TTL cache implementation work, that got updated. Um, the work on this whip primary balancer PR, is Laura here? Yes, she is. Laura,
Yeah,
is
I'm
that
here.
one of the things that you're working with Josh on?
Yes. Um, he and I are working on that together, and we're hoping to get that in, and that's just the refactoring PR. So he made some updates on the documentation, but then primarily on he made updates on what is it, PG calc up maps or something. That's what it's called. But that's the function that does all of the balancing. But it was written in a way that is very confusing and isn't very for new people to change up. So he did a lot of work to refactor that. And right now, I put it through tautology to check to see, because the desire here is that we want the balancer to work exactly the same as it has been. Code refactoring, that's all the changes we're expecting. So I'm working with him right now to check the results on that. He's doing testing of his own. But yeah, that PR is getting attention, and he and I are working together to get that in frequency, most likely.
Cool. That's excellent. Oh,
Yeah, and then that's
are you
just the
guys
first step
coordinating?
in.
Sorry, go
Oh
ahead.
yeah, go ahead. That's okay.
I was wondering, are you guys coordinating at all with JJ, I think, right? The guy that presented here a little while ago for his out of tree balancing tools.
We haven't been, or I don't know if Josh has been, but as far as I know, JJ
Yeah,
was more
I think,
focused on
yeah. Yeah, I can.
different.
Yeah, I
Yeah.
have a little more background on that. I think JJ and Josh have spoken, and they're pretty much like aware of what the problems are currently. But I think Josh's idea, essentially was to make the code more modular and like make design it in a way so that JJ's optimizations can be in the code versus like an external tool. So
Sure, sure.
he's kind of paving way for all future improvements at this point. So at this particular PR at the moment, we don't expect any huge performance gains or anything. It's just cleaning up the the mess we have done over the
Sure.
years. So we appreciate what he's doing, but essentially, we want to make sure that if we have this restructuring work merged in Quincy, then any other future improvements would be easy to backport. So that's the reason we want to get this in if things look good.
Cool, cool. That's great. All right, let's see. Radix, huge page-based read buffers that got updated. You were reviewed it, it looks like. Uh, a little bit of ongoing discussion with this making shared blob FSCK much less RAM greedy. I think last time I talked to Igor about that. Oh wait, no, sorry, I was mixing this up with his O-node memory improvement thing. Okay, it looks like Adam, maybe you reviewed that more this week. Request for testing, it looks like. Okay. Adam, do you have any comments on that one?
No, I got lost in other stuff. Sorry, was away with my mind. Could you
okay.
please share the PR number?
Yeah. I'll put it in chat here. This is Igor's FSK memory reduction PR. It looks like you maybe were reviewing it earlier this, or maybe
Yes, I was reviewing that last week, but not this week. I'm basically I withhold my detailed review last week because I wanted to for us to make a decision if we want to refactor that PR more to actually meet strict memory requirement, or we will just be satisfied with the best what that we can do, accepting the limitations of detection here. And basically, if we decide to go with it as it is, then I will review that more rigorously just for errors.
Sure. If we
So
can
still,
make it fit within a memory boundary, is probably a good idea.
I mean,
Even
I
if it's
shared
there.
with Igor the example how to create a script, how to create a really trashed instance of object store, Blue Store metadata, and I've seen that he has been working on it. So I'm basically thinking that he is really doing something with that. So, yep, I'm saving my time not reviewing it yet.
Sure. Very cool. Especially if we can make it fit within a given memory boundary. I think that's the right way to go, probably. But we'll see.
Yes, I want to have it both for Quincy and with reduced memory usage, hard cap of memory usage, but I will accept just getting it for Quincy without the second requirement.
Yeah. I think that's very reasonable. If we can just shrink it for now, and then in a later point release or something, if we can do the other version that bounds it, that'd be okay.
I was just worried that if we get it merged, it will be good enough that for the next 2 or 3 years we will not touch it again.
I mean, like if we get Igor's one merged?
Yeah, if we get merged, assuming that this one, the existing implementation is okay, we will not revisit, possibly never, the same issue, and we will just have some memory limit that is dependent on actual data structure we have, which I really do not like. Seeing that we are working more and more having strict memory cap.
Yeah.
It's something that did not exist like 1 year ago, but this year I see it's a thing.
It is, unfortunately. It's being deployed in production now with, hard memory limit caps in such a way that if we went out of memory, we could just end up seeing like cascading loops, failure loops with OSDs if they're trying to FSCK and going out of memory. So I don't know. I guess we'll see if that happens. Hopefully not. Yeah, I'm suspecting that we might have to revisit this before 2 or 3 years from now. But maybe not. Maybe we'll get lucky and we can, worry about it for Crimson or something instead.
Well, now it's definitely better, but if you have like fairly large disk and you trash it for half an hour with snapshots and random writes, you get so many blobs that your 5 gigabytes of RAM will not be enough, even for improved FSCK.
Yes, and I suspect that we are going to see a lot of deployments with 5 gigabytes of memory as the container limit. So, unfortunately.
Because if we had like one OSD doing FSCK on the machine, we could really get away with that going for 20 gigabytes. But with hard limits, there will be complaints.
Yep. So that might be something that for 2022, that might be something we're looking at more. We'll see. All right, but for now,
if we could have a solution, some way to actually make FSC some temporary modification, some procedure that we could give to customer if he gets into an endless FSCK failure loop, I think we could merge that code. I mean, not really merge, review and then merge that code now. But I do not see any easy procedure to easily modify a container and give it more memory just for FSCK and then limit it back. But maybe if we have such procedure, then we will have something to provide for customers, and that problem with hard capping memory will be not so strong, so severe.
Adam, do you think it would be helpful if we just wrote down a document explaining the ways that an OSD could end up using more memory than the container limit or even the OSD memory target? Like, we know how this kind of all works internally, but it's a common question that comes up.
I think we should. We just have to do this.
Yeah, exactly.
I'm not really eager to do that because it's not easy to find all that conditions that make us really overblow memory usage. But yeah, we should. Especially that after your control of the cache sizes, we have at least some control on how fast we will increase in memory size. So if we just identify the few remaining conditions, like maybe recreation of allocation map that Gabi made, maybe FSCK. Definitely FSCK is a stronger consumer of memory of all that I know.
Yeah. Was there something with Scrub or snapshots or something that I forget what I'm thinking of? There's something that was potentially unbuttered.
We tend to be pinning very many O nodes during Scrub.
Okay.
but that's not something that we can easily modify.
Yeah, yeah. It might be something to document though, as an explanation for why we could potentially go over memory limit. Yeah, I think we should do it too, Adam. Maybe a good New Year's resolution to actually sit down and document all of these things.
Okay.
I can try to start it, at least with the stuff I know about. All right. What else? Well, then your fine grain locking PR. So it looks like Igor reviewed that and you're getting good feedback on it.
Yes, I was very happy this time. He found a lot of errors and I fixed all of them in one day, meaning there was no critical hiccups there. It was just easy errors. I assume next round of tests will be as successful as the one before.
Okay. Sounds good. All right. So, did I miss any PRs from anyone? If not, the only other thing that I had that this is from a couple weeks ago. We didn't have time to talk about it, but I I sat down with Ben England. He's one of the performance guys at Red Hat. He had been trying to do some testing of stuff on top of Amazon EC2. And one of the things we noticed as I was trying to help him through diagnosing some performance issues he was seeing is that these EC2 devices, they're supposed to guarantee a certain number of IOPS. In his case, I think it was 6,000 IOPS. But when you do OD sync writes, like say how our journals or how the Red Hat log in RocksDB works, and in fact, it could only do about 1,500. And there had already been some concern or questions about Ceph not fully utilizing the underlying devices, not seeing 6,000 IOPS, this kind of thing. But what I was wondering as I was looking at this is I don't remember exactly in the right path with our transaction model how much we can combine into a single transaction in the write ahead log. And I want Adam, I don't know if you've looked at that code much. I was hoping I might be able to ask Igor, but I was trying to figure out how much write combining we can actually do there and if we can do more.
I'm not even sure if I fully understand your problem. I don't think there is any limit. We are packing incoming BlueStore operations into one transaction, and then we just commit it in one. We add it to RocksDB write-ahead log, and then we commit it, and then we start a new cycle. I don't think there is any hard limit.
So typically when I've looked specifically at write-ahead log writes, I don't see them get very big. I mean, kind of big, but like 7K on average. I don't see like us combining. Well, maybe we are. Maybe it's just due to whatever limit we have set for how much I/O we do at once. So maybe that's really the amount of memory for the number of concurrent I/Os that BlueStore deals with at once. Maybe that really is how much metadata we have for it.
I remember, and that's typical for some tests I do, to have a write-ahead log being produced in megabytes per second. So
Sure. And how many IOs per second, though?
And that's tricky. Which IOs are you asking? IOs to disk or IOs to Ceph?
IOs to disk, specifically the write-ahead log disk, whatever that is.
On officinalis, the length of a cycle write-ahead lock syncing and the next iteration is about 4 milliseconds.
Okay. So I guess the takeaway for me when I was looking at this is that it appeared that in some of these tests, the performance basically was bounded by the OD sync write performance of the underlying wall device. So by batching more together, it seemed like even with much larger writes, we could still achieve roughly the same latency. So like instead of 7K worth of metadata, if we batched more like 16 or 32K worth of metadata, we saw almost the same latency to the disk.
This is consistent with my observation during testing.
So yeah, maybe it's just a question of allowing more concurrent I/O blue store then.
But that's just changing condition of a test. Because,
Exactly.
for example, if I do have 64 transactions on the fly, then that's my limit. I know that if I push it more, then I will get more IOPS, but there is a limit when I'm no longer interested in squeezing more IOPS. I'm more interested in actually having some realistic value and get the feel how latency affects my performance here.
So when we were beginning this discussion, my thought was, oh well, 7K isn't very much for metadata. I was thinking that that especially if we were including a small writes worth of data in the transaction, that 7K was probably not, it was maybe like two IOs worth of metadata, but that might not be right. It's probably actually just the metadata for many more writes than two.
But to clarify, are you stating when you state 6K IOPS, does it mean that latency for syncing one IOP is about 125 microseconds?
No, because they kind of lie, right? In reality, you only get about 1,500 IOPS when you're doing sync writes. So the latency is actually higher. They just don't.
Cool.
Yeah. So and that's on the EC2, setup that he was running. I suspect that it's because in reality EC2 is like a networked block device. It's not, local disks in the system. It's, going over the network to whatever EC2 is behind the scenes. So the latency really isn't that good.
Usually he's testing GP2, so it is definitely a network device.
Yes, sorry, GP2. I said EC2, but I meant GP2. Yeah,
EC2 is right. Is the overall, but one of the flavors is GP2 that we're working with. Yeah,
and that's what he was running on. It was on top of GP2. Yeah.
Well, we can always skip waiting for sync to commit and continue.
Yes, I suppose. So anyway, I just wanted to bring that up. I wonder, Adam, if it would be helpful if we added a performance counter for the average number of IOs per transaction that's going to the wall, just so that we can verify and see.
I think we do have it already, kind of it, for KV sync thread. There is a counter. Yep, I remember. Now I don't recall the name, but I remember Igor adding such feature.
I'll have to take a look.
Let's synchronize later about that, because I also want to look it now, but let's not be unpleasant to other people.
Yes, yes, I agree. I agree. Okay, that's all really I had though. So, if anyone else has anything they want to talk about today, go for it. But yeah, otherwise, that's it. All right, I'm not hearing anything from anybody.
Yeah, nothing more
So,
on my end.
all right. Well then, folks, have a wonderful end of your 2021 year, and we'll see you guys next year in 2022.
Thanks, Mark, for a good meeting.
Thanks. You
Thank
too.
you.
Thank you,
Thanks.
Mark.
Have a great
So,
one,
Okay,
guys.
Thank
thanks.
you.
Bye.
thank
Take
you,
care.
guys. So we look at that
Bye,
counter
everyone.
now.
Happy holidays.
Yeah, sure. Let's do it, Adam. I just did a perf dump, and I see some KV perf counters, but I don't see. I see latency related ones. They're all latency related.
There's always an option for me to be incompetent and remember it wrongly.
Don't no, it's not incompetence. My memory is awful too now. So I just did that to grep for KV. Do you think it might be named something different?
There is something KVQ submitted. No, that's a queue. Why I distinctly remember there was something that allowed to track how many IOs we pushed into a single stage of our state machine.
Here's I looked for while. So that's like bytes written. This is interesting that the while total bytes and the while used bytes, these must be what's currently there or something because this cluster is idle right now, but it's not reporting anything.
Yeah, interesting.
Transaction. I wonder if transaction appears anywhere. Nope, no transaction. RocksDB maybe. There's a write while time and write memtable time.
Sorry, I'm talking to myself. That will be a RocksDB time, and since in BlueStore we only use RocksDB for metadata, it will be exactly that. Maybe.
Yeah, I don't know. I don't remember ever having anything like that, Adam. But that doesn't mean Igor didn't add it. I just have never used it if he did.
There is a dout on level 20 that each time prints a KVQ size and KVQ submitted size.
In bytes or
In items.
items, okay.
Yeah, I was wrong. It's still possible that I added that to some tracking tools. Never committed that, just used it. And
Sure.
everything got blurred.
Yeah, it happens. But that might be a good thing to add.
Yep.
We could see especially if we had both the average number of items that went into the transaction and then the average size of the transaction, we could maybe get an idea of if we are running on top of a device that has high latency, if tuning things differently might help.
There is that PR that I don't want to be merged yet about controlled latency using Codel algorithm that was intended to control how many write operations we put through BlueStore, so we could control it, make some usable throttle there. So yeah, that definitely plays in a role of being useful metric for any adaptation algorithm.
Yeah. It's interesting too. One of the things I've seen is that so Micron did these tests years ago where they changed a bunch of the RocksDB settings and they made it so that the size of the mem tables was much smaller. I think they made it instead of our default 256 megabytes, it was like 4 megabytes. And one of the downsides of doing that, right, is that you have much higher write amplification in RocksDB because of pglog updates getting into the database and that kind of thing. But these very small mem tables mean that it's much less work keeping them in sorted order.
Okay. Again, if we don't have a predictive model of managing caches, it's basically useless because it's just guessing each time.
Yes. The thing that I found interesting about it, though, is that those unfortunately those settings have persisted as an idea that populates into different people's heads, and they just go use it, and they say, "Oh, hey, maybe I see 5% faster performance, so it's better this way." But they don't realize what the effect of it is that they have much higher rate amplification now.
On the other hand, I'm not really bothered with higher write amplification. I mean, the endurance of a device is, of course, hit by it, but I'm not really a worrier about that particular metric. More, I'm afraid that it will also affect read amplification, meaning I will be losing my cycles to read from the device if I have small table and I have to visit multiple tables just to get my filter responding that I don't have a key.
Yeah, that's also possibly true. I don't know if RocksDB, when you get to deeper layers, if those would grow significantly larger, right? Because the mem table coming into level 0 will be very small. I wonder if then it combines things as it goes deeper.
If you have smaller level 0 tables, then you will kick, of course, more often compaction.
Yeah.
There have been scenarios when doing aggressive writes on compressed blocks when I was able to basically push compaction limits, meaning that almost always there was something being compacted.
Yeah.
And I'm afraid if I pushed it even harder, then I will get stalls because of having too many L0 tables.
That's a good point. And related to that point, I think sometimes when people test an empty RocksDB instance, the write amplification is no problem. So trading at write amplification for lower CPU usage is good. But maybe when they fill it up, having more write amplification now all of a sudden is bad when they've got much more data. And that trade-off was a bad choice, even though it looked better at the beginning.
I have the same problem with our allocators regarding HDDs. I'm really not sure that after half a year of actual work, the strategies we have in disk allocators are really useful.
Yeah.
But we never had a chance to actually test it that long.
This is the trade-off for ditching the file system and doing it ourselves, right? Instead of letting
Yes, but what's the alternative? Do you really think the other guys really did that too?
Well, sort of. At least there's been more testing.
Yeah, initially. But now
Yeah.
we really have some backlog of testing.
Yeah.
I remember like 2 years ago, I was really scared about stability of BlueStore and actually putting it into production. Now it's like, it works. You have to work very hard to convince me that there is something fundamentally broken there.
Yeah, I agree with you. Now it's more of a fear of breaking things by changing too much.
Yeah, tell me. Tell me. Yeah, but I want my additional 5-10% IOPS, even
Yeah.
more.
Well,
You know, I tried again on top of fine incremental update. I put then on top of that fine grained locking, and on top of that, I put my modification that got always direct writes even in buffered mode. And I'm still getting almost twice as much write IOPS.
really?
So
Wow.
that was not a fluke of some past strange
Oh,
test. Officially still shows that.
wow. Okay, that's good.
Yeah, that's strange, and I want so much to try it. I mean, now it's too early, but after fine grain gets merged, that will be a good moment to work on that forced direct write.
Yeah. Did you see the Crimson presentation I gave to the engineering meeting?
I'm sorry, I did not.
It's okay, but I wanted to let's see here. I want to do the quarter 3 one. I wanted to show you a slide from this because the tests that I did were with BlueStore in both cases. And let's see, this is the slide I wanted. Okay, so look at. I think you should be on the right slide if you look at this.
Architecture differences, latency, that's the slide I'm seeing.
Yes. So this is Crimson and Classic, but both are using BlueStore. And look at the reduction in tail latency when we instead of the classical SD code.
Wait, I do not know how to read that. Lower is better, that's obvious. Left is okay. There are two architectures, and the left is okay. The blue ones are classic, and red ones are crimson.
Exactly.
Okay, so average latency is twice as small. but tail is significantly smaller.
Exactly.
And both of them are running BlueStore.
Correct.
This is very, very, very strange. It would mean that most of the latency is that other part.
Exactly. That's in the either the messenger threads in that piece, or maybe in sharded up work queue.
Yeah. Okay, whatever this is, it's really a good news for BlueStore.
Yes, really, it's good news for Blue Store. I was amazed when I saw this. The entire reason that I started getting results on Mako on the AMD nodes was because I didn't believe this result when I got it in Officinalis.
Yeah.
I said, these numbers must be wrong. I did something wrong.
Yeah, and you switched architecture, and yeah, that's really good.
Yep.
Okay.
So interesting, very interesting that to me in Classic, it looks to me like we could see significantly lower tail latency with Blue Store if we could fix whatever else is in Classic is causing this. Oh, bye, whoever. Uh,
Bye. Have a good day.
Yes, happy New Year. So yeah, I thought you might be interested to see that though.
I am interested. I mean, even just for being happy that it's working so well.
Yes, exactly. And I suspect that that might mean that if I made a larger Crimson cluster running Blue Store, that the overall behavior would be much better. If individual OSDs have much lower tail latency, everything should be much more, much smoother.
But it also shows that Crimson shouldn't be much faster in random writes than Classic.
Right now, it doesn't appear to be, with Blue Store anyway.
Yeah, but Blue Store, okay.
It's a little faster, maybe. But actually, it's not if you have lots of CPUs, because you're limited by the reactor thread. We do so much work in the Crimson reactor that is in other threads in Classic that you can only use about 2 to 3 CPUs per OSD right now.
Okay, in any rate, I'm still looking forward to cut that latency in half. I mean, I expect that if I have twice as much IOPS, it means my latency will be twice as small because I have a fixed 64 ops in a queue limit for testing. I have to test on something.
I've been thinking a little bit for a while about trying to replace the sharded op work queue with a lock-free implementation.
Okay, I will leave you to that. I'm not.
You don't think so?
I lack competence to even challenge your belief that it will bring an improvement.
I don't know that it necessarily will. If it's not that, then the only other thing would probably be Messenger that I can think of that would be a likely candidate. And I don't know anything about how to make the Messenger better, so I guess that's why I haven't focused on it.
Yeah, I mean, there are quality attributes that I think we neglected a bit, especially reliability of getting stable, just QoS for writes. We currently just put everything to BlueStore and there is no control. And that's a very good observation from Sam that we really should give some ability outside of BlueStore to control incoming ops flow, because now we're just aggregating everything and increasing the latency, which might not be a good way.
When did Sam comment on that?
That was mostly on the review of Codel and the discussion about Codel PR movies and movie recordings
Okay.
of.
Okay. Yeah, I don't think I was involved in some of the discussions, so I don't
Neither
know.
was I, but I just got it to make a review, and I had to reintroduce myself with the topic.
Sure. Okay. As we talked, the other thing I was thinking about is I think for the messenger threads, don't we allocate memory in messenger threads that then we free in other threads later?
Yes, it's very possible.
I believe we do. I wonder if we should consider trying to
Having a back loop of that, making a for loop of that memory, and
yes.
if not reuse, then at least free it in the same thread.
Yes.
That might be true.
I
I'm
wonder how tough that would
working
be.
a lot with Gabi, and he gives a very valuable experience of totally different programming model than what we have here, and his constant complaints about varying op sizes and unpredictable memory usage per one op, which I really got accustomed to, really are refreshing bit.
Yeah. I had the very similar complaints that he did when I kind of dug into Ceph initially, but
The bad thing is I really got accustomed to this behavior, and it no longer annoys me that I have to allocate dynamic structure as a temporary object.
it's very comfortable.
Yes, it is.
Yes.
And I'm not even sure that we can escape that pattern now, but I still dream of changing a BlueStore in a way that some basic I/O patterns could be fully predictable, and I will not need to allocate some unpredictable extents, blobs, and stuff like that.
I wonder, as we theoretically move closer to Crimson and having BlueStore running Crimson, I wonder if we should try to make it so that we can allocate memory using whatever abstracted memory allocator, like maybe if it's Crimson memory allocator, we can do some kind of upfront memory allocation and just try to start moving BlueStore toward always using our abstraction for allocating memory instead of directly doing it. Maybe we can then, if we do that, maybe we can start to.
I would love that.
Yeah.
I imagine it will require us to do full revamp of most of low-level metadata modification procedures, so we could pass an additional handle. Okay, you're modifying your data, but here is your handle for allocator, and you have your data always tightly coupled with this stuff, whatever this is. And So you could keep that as a simple data packet.
Yeah.
I mean, ultimately, my thinking is I would love it to see that if we are operating heavily on O nodes and then we switch pattern to something else, then instead of what we've seen on your test that we have to go really deep before tcmalloc can find you 4K page, we will almost immediately be able to reclaim something. You just free 100 objects, and here is your continuous few pages just here.
Yeah. Yeah. Hmm.
But for
Yeah.
that would need to be a bit different data structure.
It'd be interesting to even just do an audit of where do we use new and free, right? Like,
Don't we know that already?
well, in the abstract, yes. I guess I was thinking not only where in the code we do it, but as we work through an actual workload, where do we use it the most? Like, how do we use it, I guess, is maybe both where and how.
Okay. So you want to make a plugin for your wall clock profiler that will catch all mallocs and frees.
Yeah, kind of. Did I show you the link to this heap tracker?
You did share a link to your work on your wall clock, but I did not look at it.
No, not mine. This is somebody else's. Just a second. I know he had a blog article about this. Here's the link I was looking for. Look. So I'm thinking of stealing his idea.
No, it all assumes that allocations are really a problem in our case, which probably is, but
Yes,
I'm
that's
just adding. I will stop that sentence with but.
yeah. I think I want to at the least go look at, try to find the situations in which we allocate new memory in one thread and free it in another. I know I've heard over the years that we do it, and I've never actually gone and tried to figure out where or how often we're doing that, how bad it is.
The most prominent hunter of such events was Radek when he was playing a lot with Bluestore and Perf, and he found at least two places where we released memory in proper thread, hitting us with hard limits of tcmalloc arena lock.
Yeah.
No, global lock, not arena lock.
I would have assumed that if there were easy fixes, Radek probably would have made a PR to fix it too.
We fixed that. We moved
Oh, you did?
the allocations to finalizer thread.
Okay, good. And he didn't notice any other ones then, besides those ones.
No, because you actually have to make a test that aggregates a problem and run a perf profile and see where you see a lot of TC-malloc latency, and the ones that do wait on lock, and that part was difficult with perf to obtain.
I wonder if you
But
could.
since that time, I found that there is a software event in perf that actually lets you work almost in a wall clock mode. You just use a not hardware counter, just a software CPU clock timer.
Okay.
And then it gives you something very close to wall clock analysis. I used that because on Raspberry Pi, there was no hardware events and I had to fall back to this software one. And it was surprisingly useful.
Okay. I always had wanted to find a way to make perf work like that, and I wasn't able to do it when I tried years ago. That was why I made the first attempt at GDB PNP, was because I still couldn't figure out how to make perf work in a wall clock like mode.
And I will refresh my memory and share what I did. I think it's still in the Raspberry Pi history.
Okay.
I will share what I had. Maybe it's exactly that.
Okay. It'd be neat if you could write a tool that would trace memory in such a way that you could find out if the new and the delete happened in different threads. Like if you could then log those things.
There should be a plugin for Valgrind like that.
Yes, I agree. I don't think that there is, though. I mean, maybe I just don't know about it, but that would be super useful to have something like that.
If not, you can always make a wrapper for alloc free. It will work.
Yeah.
If I clone myself, then I will gladly do that in a second fork.
This is why I think too, though, that we should have our own wrappers around new and free anyway, and we should be able to then control all of this.
I don't think so.
No?
I'm already thinking that the way C++ is treating its new and free is basically causing us a lot of harm. Because there is no way for you to actually, in any meaningful way, bind a allocator context with neither instance nor class of thing that you are invoking for the new for. I mean, if you have new int in some place in code, there is no way for you to say that now this int should go from this pool, not that pool. And I agree that in most of the cases, that distinction is not really useful. And I don't expect the language will allow for such distinction. But in case of our persistent, not really persistent, long-living caches, it really makes much difference.
Do you think that in situations like with the messenger threads and the whole model of the classic OSD and Blue Store, where we have these TP-OSD-TP threads, and we have the KV-sync thread, and we have separate messenger threads, and data needs to be allocated somewhere and then removed somewhere else. Do you think that we can reasonably change that to something that behaves better with memory allocators? Is it a worthwhile endeavor?
I think that is a worthwhile endeavor. I think we can really squeeze some serious cycles, especially on large ops, if we, instead of relying on allocator, we just have some policy of tick-click buffers plus stuff, something similar to what you made with Radek some time ago.
Yeah.
I believe that's useful. I mean, especially for messengers, because I do not expect anything in a messenger will live longer than a second. If it is, then that's exceptional exception.
Yeah. And the thing with Radix, the work that he did that was so good with it too, is that it's almost transparent, right? That you just fall back to the traditional method of allocating memory. It doesn't fit.
That was very good.
Yeah.
But yeah, that pattern is not universal. I mean, it's useful here, and possibly could be also useful in BlueStore if you make a transaction, because we transform a transaction from during queue transaction operation, we transform it from whatever we get into a BlueStore internal queues. That also could be made as cyclic.
Yeah.
But
And
still,
we do that so much that, yeah, I mean, it would fragment memory horribly, right?
strangely not so, because we have our tcmalloc that keeps us in bins of some sizes. That really helps.
Yes. But it probably helps explain why
the problem is when we mixed that with some data that we just allocate some extents for a new blob, and we just put it here.
Yeah.
That's why I'm complaining about not being able to tell C++ that no, for that you should use another context and another allocator somewhere else. And then I will factorize BlueStore into parts that I think are longer lived, like any on-node data, and something's just short living and
transient,
having that totally separate. And I will have much better chance of it working nicely with fragmentation. But yeah, I cannot do that. It requires actually handcrafting allocations.
What I was going to say earlier too is that tcmalloc can sometimes deal with this kind of thing, but with libcmalloc, it's much worse. It does not.
Yeah, it's much
divide
worse.
things into bins.
It's much worse. And being honest, that's actually a reason why I want so much Igor to revive his PR on smaller metadata for BlueStore, because the lot of techniques he used, he just passed an extra parameter, and we no longer had the pointers going from blobs back to objects, and you had to, doing any operation, keep the reference to your own node with you.
Oh.
Things like that. And
yes.
He squeezed a lot of pointers that way, and the side effect is he had to pass that.
That's actually really nice. Oh. Yeah, I don't really like the design of how all of the data structures it's all, I don't know.
So if you were in a mood of complaining about that, I think you should take a talk with Gabby and you will be satisfied. And he's right. He's right. I mean, it was for me unthinkable that you can make some persistence, data storage persistence, without having actually defined how your objects is structuralized, meaning in bits. Actually, we don't have that. On neither level. We have a C++ structure, then we pack it into bits and then store in RocksDB, and there's nothing in between. There's no level between being a C++ struct and being a bitwise stored on media.
Yep.
Okay, that's what it is.
Yep. And speaking of complaining, even as I think about that and the encoding that we go through to store that as basically like a bit stream, there's so much overhead there. It's all just, I don't know.
Yeah, we are now complaining that there is an overhead, but when we did that with HDDs in mind, we gladly paid all that overhead just to have it smaller and being able to serialize and write in one long write to the disk. We gladly paid that. So I'm not really eager to very much complain about the previous generation of engineers that decided that it should be like this, because I understand that it wasn't on a whim. It had a real usefulness to it.
Yeah, it was not discussed very much. Let's put it that way.
That I don't know.
I do, because I was there when it happened. But yeah.
Quickly, turn off recording.
No. But no, the upside of it is that we Blue Store was up and working after a fashion very, very quickly. I mean, within a couple of months, the basic Blue Store implementation was done and working, which is insanely fast.
I'm amazed because that's even in smallest form, that's a huge project.
Yeah, it was crazy. And it wasn't a bad decision for hard drives. You're right. It's just now I guess that's why we're doing Crimson.
Still,
partially.
As I hear, there is a lot of customers that really want to have
I lost you,
very cheap.
Adam.
Hello. Now, do you hear me?
Network. Yes.
Okay, it was perfectly fine on my side all the time. I heard you complaining that you lost me. How about now?
Okay, it's starting to break up for me. Like
you are perfectly audible.
It's freezing a lot. Let me turn off my camera. Maybe that will help.
I also switched off mine. How about now?
Hey, Adam.
Hello? Hi,
Oh,
Mark. Do you hear me?
hello. I do. Maybe it'll work better now. We'll see.
Mm, well, maybe it's time we should just finish. I don't know.
It's possible.
Uh, uh, okay, I just wanted to say something and it interrupt me. Um, about that I still believe that spinners will be used for some time. I thought for some part of time that it will be just going completely out, but I see some operators really want to use the cheap bit storage of spinners, and that will not change very soon, especially with that SMR drives that gave additional, I don't know, like 50% space.
Yeah, yeah. Yeah, it'll be very interesting to see what the model looks like with BlueStore. I suspect that we'll see more and more those kinds of drives with, very fast, small amounts of fast storage for the wall and DB.
My imagination is that we will see a deployment that you work like this. A pretty weak machine having maximum possible amount of spinners mounted and one max 2 SSDs or
Yeah,
NVMEs for metadata, and that will provide some, let's say, not prime sort latency for data access, but it will be cheap, memory will be limited, and that will be like this.
yeah,
I'm just inferring that from the observation that we are working on hard limiting memory usage.
yeah. It was very interesting because that's what the direction I've been getting from the the OpenShift or ODF folks. But then I heard from one of our big users that they just upgraded all of their machines to 384 gigabytes of memory because it was very cheap. And they said, why not? So I
Because
think,
it was cheap in an age of chip shortage.
I don't know. It's like I hear different things from. I think the smart people, like this user that we have, they're like, oh, we can spend 40 or $50,000 and have 384 gigabytes of memory in all of our nodes, and then memory will not be a problem ever again for us. And
Yeah,
then
maybe.
other people are like, well, no, we have to make these as cheap as possible.
Yeah.
But it's only cheap from the hardware perspective. It's not cheap from all the time that you spend and pay people to fix all of your memory related problems when you do that.
But you don't count that if you use open source.
I know it's free resource, right?
It's free. It's free.
Yeah. All right, Adam. I think I'm going to go and
Oh, I'm sorry. I'm just as one of our colleagues told almost half an hour ago by two
yeah.
experts. It seems like a suggestion now.
Yeah, yeah. Well, you have a wonderful end to your year, Adam, and
Yeah. Have a
I
happy
will.
holiday and a great new year, or in whatever mixture of
Yes.
fun and family and maybe work if you like.
Yeah, I was thinking I'm going to try to do my idea for the wall clock profiler for trying to see if I can
No. I think you should try if there is something other than work that you can
oh
do for fun.
Yes. I keep telling my son that I might make a video game, so we'll see.
Uh, how many video games did you made in your life?
Not very many. I think I've made it like two, but they're both very simple.
I think I made like 10, maybe.
Oh wow,
If you include versions, maybe more.
this is
Well,
impressive.
I had to. No, no, really, it's not. You have to do something with your Amstrad computer to be able to use it when there is no software and there is no internet and there is no way to download anything.
Yes, very true. Adam, do you ever play like uh space simulator games?
That's the only stuff I play.
Do you
My
know
Yeah, continue.
do you know the X series games, X2, X3, X4?
No, I do not know what you're referring to.
Oh, okay. They're very complex space trading simulator games. So kind of almost economy games. Um, let's see. Uh, so like this is one I used to play a lot.
Okay, I play that.
Oh, I've heard of this. I've not played it though.
It's basically um, it's a game on top of entropy simulator, meaning energy balance simulator. You just have an environment that has its temperature, and you have to basically manage your world not to overheat, and then provide the oxygen to your people and get them out of chlorine and hydrogen because they don't like it. And that's basically it.
I have been looking for a game to give as a Christmas gift to my kids. Just something, a little gift. I wonder how much this costs on Steam. Maybe I'll get.
Uh, I always think software is cheap, especially if you burn like after some time 2,000 hours after 2 years, and it means it's however much you paid, it's cheap.
Yeah. Have you ever played Factorio?
Uh, no, I've seen that, and I was even considering playing
Oh,
it, and
it's
I dropped it
fantastic.
because I've noticed that it's fantastic. I just stick to that one, so I do not have too many games.
Yes, yes. If you want a new game, get Factorio. It's great. Someone figured out. So in Factorio, you can build logic gates. You can build computers in it if you want. Um,
It's
and
like Minecraft.
someone,
It's like Minecraft then.
yes, yes. And someone figured out that they could use uh, the railroad signaling logic in it to build a wireless implementation. And they created TCP/IP on top of it and made a full wireless stack using the train signaling system in it for wireless communication.
That's exactly how I want to consume my games. Push them up to absolute limit and some more.
Yes.
That's the only way I like my games, when I can cheat in basically abuse physics that it's presented, not really exploit bugs, but abuse physics. I'm just very satisfied them.
Oh yes, you should play Factorio. It has many opportunities to do creative things like that.
I do exactly that in Oxygen Not Included.
Okay. Oh,
Anyway, Mark, so don't work, have fun. I'm considering playing a lot this and also play my Legos and not really want to work, although it's really tempting because I expect tautology will be totally empty in the meantime. So my runs, 400, 600 runs on Rados will just execute immediately.
yes. All right. Well then, have a excellent break, Adam, and I'll see you next year.
See you next year. What will be that? That will be Tuesday? No. Monday. The 3rd is on Monday. So,
Is that when we come back? I don't remember. Probably,
well, I
right?
assume the 3rd of January 2022 is when we go to work, finally.
Probably.
Probably. If not, then Tuesday.
All right. Sounds good.
See ya.
See you later, Adam. Bye.